Hello, everyone, and welcome to another Lambda Ethereum Consensus Daily. And as always, let me share the YouTube link. And that's it. We are live, and it's already on Telegram. So, updates. Yesterday, I was working in the beginning of the day with pushing the things that I forgot in private regarding the PR of the refactor, and it was pushed just early in the day, and it was ready for review. And then I continue working on the debug issue regarding the 2% blocks missed. I was the whole day working on that, and in the afternoon I found what was the root cause, and it was a pretty quick and easy solution. I think was finding it, but it was related to a filter that we were lacking, that I were lacking regarding the root, right? So we were receiving both from other nodes and from ourselves the message broadcast of the sync committees. And what was happening, and it was happening just in the first slot after every epoch, was that due to a delay, we were processing the notify blocks just after the second period, the second third of the slot, right? So in the second third of the slot, if we don't receive a new head, we just publish an empty sync committee message. So when we publish as empty sync committee message, we use the previous root. And given that we were like publishing that and just immediately receiving the new root, when we try to create the sync aggregate for the next block, we have that incompatibility, right? We have a new root, but we were having contribution message targeting the other. So the only thing that was missing there was the filter regarding the root. When the filter was in place, we started getting a sync aggregate of zero, in those particular slots that were missed before, and everything started working again. One of the things that I noticed was that this was taking a lot of time, right? So it was taking 4 seconds. So I added a comment regarding that, and given that I'm right now working in the duties and adding the subnet the subnet precalculation to the duties to have it ready for an early subscribe in every slot, I'm also in the meantime testing and measuring how much this is taking. And yeah, I'm just looking at this. If it's easy to solve, I want to solve it in this pair. If it's not, I'm going to create an issue and put all the information we need there. So yeah, that's it. That's ready for review. It's already there. And thanks, Tommy, for the review on the other one that it's already mentioned that you mentioned. So that's all my updates. I'm going to continue working today, both in this measure and the subnet info early subscribe. So I'm working on this at the same time because it's mostly the same file. So yeah.
All right. Great progress. Thanks for the updates. I have a couple of questions, some related to the delays and some related to the solution. So let's start with the solution first.
Yes.
You mentioned that you added a filter, right? I'm not sure I understand what kind of filter is that? Like what thing are you filtering?
Yes. Okay. In the spec, when we read the spec about the validator sync aggregate process, one of the lines is that it assumes a couple of things in the function that is shown. One of the things that is assumed is that this is for the previous slot, so we are just processing contributions for the previous slot, and the other one is that we are just processing contributions that match our current root, right? We do this also in the attestation aggregation, right? For example, in the subnet info, one of the things that we do is that we create the subnet with a particular attestation, and then we just add the attestations that match the same root. This is also done in the sync committee, right? So we create the subnet info for the sync committee with a particular sync committee message that has a particular root, and all the others need to have the same root. But in the sync aggregate, we are one step ahead, right? We are in the next block. And in the next block, we need to make sure that that root doesn't change. So we need to also filter it again in the sync aggregate, and we need to have the slot, the previous slot -1, and also filter it the ones that doesn't correspond to our current root. Those are the two filters that need to be just in the beginning. They are not part of the code that is in the spec, but it's part of the explanation that those are the prerequisites. And yeah, I was assuming that the other filter, the one in the subnet, was sufficient, but it was not, because if we have a delay, if we don't receive the block before the second third, we publish a message broadcast with no new root. We are using the previous root, and that's what happens in the next block. This happens exactly in the epoch boundary. That's the one that takes more time. And in the next block, we match like, hey, we have a new root, but all our contributions, even the ones that we publish, are targeting an old root. And that was the validation error. The error wasn't so clear. It was related the signature validation error, when in fact it was related to the root. But yeah, that's another thing that we could probably enhance. But yeah, it won't happen again because it's already solved.
Yeah, that makes sense. So just to make sure I understand,
Yeah,
when we filter out,
the contributions we collect.
right?
So the operations collector gets all the contributions,
Yeah.
and on those contributions we filter the ones that just are related to the previous slot, and also the ones that also match our current root.
So we are making sure that we don't include the new contributions that are for the next route that we didn't get yet. Is that the case, or we are?
The case is it's the inverse. So we
Right.
need to make
Yeah.
sure
Okay.
that if we are in a new route, what will happen
Ah.
is that
Okay.
when we calculate the domain and the selection proof and everything, we are using the new route, and then
Right.
the signature won't match because we calculated all these aggregate with the signatures that are using another route, right? So
Right.
that's why the signature failed. The
Mm.
exact reason for the signature failure was because of the root that was different, and it was part of the calculation of the signature. But yeah, that's the why.
Signatures are tricky businesses, right? Like, of
Yes,
course, like they are very prone to hiding problems. Like,
yes,
usually when you
they
see bad
surely are.
signature, it's almost never related to signatures. Like, it's something else that happens, and the message is not what others are expecting, so the signature appears as wrong. But you don't have any way to tell what's the part or the thing of the message that's wrong. You just know that you have a different thing from the other guys.
Yes, and the first thing that we have last week was related to aggregation bits, and it was pretty clear to see it because
Yeah.
we can see that the aggregation bits are not matching what we expect. Once that was solved, then it was more tricky to find, okay, what part of the signature is the one that it's not correct, right?
Right.
We are getting the incorrect group keys. Are we getting a different route? We are calculating it for a different epoch. That was also something that I was testing. Was it happening that I used a different epoch in one part and in the other because it was in the epoch boundaries? Well, it was related to the root in the end, but yeah.
Very interesting. So actually, it was timing, right? It was that we were getting a delay in receiving the block, so we
Exactly.
didn't get the route yet. So there was a almost a race condition there.
Yeah,
Um,
it was related to, we were receiving the block in a timely fashion, but given
okay.
that it was related to how we are managing right now the libp2p process, right? Because
Mm.
libp2p has, it's like an all avenue for everything, right? So
Yeah.
we
Right.
receive the block, but the ticks are continue there. So every time we have a tick, it's created a new message, and even if the second third already started, like, I don't know, like 1 or 2 seconds, one of the things that happened was that that message was processed before the one of the new notify block, right? But
Oh.
we already have the root, so the block was already there, the thing was that when we received it and we pushed the message to, hey, process this block, we also have in the queue the message of, hey, we already passed the second third, so we need to handle the tick first. That's something related to how the leap P2P is like this God model, having the avenues for all those things. One of the things that I saw and I added to this comment is, even if there are two things, right? One is why it's taking so long, but even if it's taking so long, this is just happening once every epoch. So it's not just a matter of time. If we just make that an asynchronous task, that's solved, because hey, how much times this could happen? It could happen once every 32 slots. 4 seconds every, I don't know, 12 minutes. It's not something that we need to care about, because the look ahead is for the next epoch. So when we are calculating it in the 33rd slot, we are just calculating for the next epoch, which is in 12 minutes. So there are some kind of things that could be solved either from a performance perspective or a parallelization, different kind of distribution perspective. So yeah.
Yeah, I have a couple of questions regarding exactly that. So
Yes.
what I'm curious is, do we have isolated the part of the code that's taking much time? Is it epoch
Yes.
processing?
Yes. It's the not the epoch processing. It's
Not
part
state
of
transition.
it's
It's the
it's
validator, the
it's
duties
not a state
calculation.
transition. So we already have a lot of things regarding to epoch processing in the epoch processing part, but we also have a lot of them in the duties part.
Right.
They are not in the same, so they happen almost at the same time, but they are like different things, right? We have
Yeah,
the
yeah,
epoch
of course.
processing in the state transitions, and we have the duties calculation that also
Yeah.
happens in the epoch boundaries, but
Mm.
in the duties model.
And
That
do we
was
know
was taking
approximately what part of the duties calculation is
the
taking so
sync,
long?
the sync committees. Yes,
Oh,
I measured that the sync committee calculation was the one that was taking almost 3 seconds. So there is
yeah.
something there that is not correct. So I'm going to, if it's easy, I'm going to solve it in this PR. If it's not, I'm going to create an issue to tackle it.
I mean, this is an arrow in the dark, but it might be related to what I mentioned last time, which
Yes,
was,
it might.
yeah,
Yeah,
like
I agree. I agree that it might be related to that, because yeah, it could be related to the fetching of the.
although, like you're testing in kurtosis, right?
Yes, that's the
Yeah.
thing that scared me a bit, right? Because if in kurtosis is taking 4 seconds, how much time
Yeah.
would it take in testnet? So I think there should be something like wrong. There should be something wrong, because
Probably, yes.
proposer's calculation took 60 milliseconds, a tester's calculation took 50 milliseconds. This couldn't take 4 seconds. There is something that is
Yeah.
not correct, and I need to measure it and just solve it. I'm pretty sure that it was something that could be solved easy, but yeah, I need to find it out. But I'm going to at least start measuring and having an idea of where the bottleneck is. In the meanwhile, I will work in this subnet issue. And yeah, if it's easy, because I hope it is easy to solve, I'm going to try to solve in this PR.
Nice. And just one more question before I
Yes.
finish all of my questions set. But do we have? You mentioned parallelization, right, a couple of minutes ago, and I think
Yes.
it's of course a very like early optimization moment to go
Yes.
into parallelization. But
Yes.
I wanted to ask, so what you were thinking about parallelizing was the calculation of the duties, right?
Exactly. Given that it's a
And,
look ahead
yeah,
thing, right? Because
right,
we already have this epoch calculated. The thing that we are calculated at the start of epoch one is the duties for epoch two. So that could be
right,
completely parallelizable. We don't need
yeah,
it until 12 minutes. So, but it's an early optimization, because probably we need to know why it's taking 4 seconds in the first time. So yeah, that's the thing, that we need to
yeah.
first know what is happening, and then that's probably something that could be easily parallelizable. Yes, with us, just
That's
a
a
task that does it, and yeah.
yes, that's a great example. I would even add an issue for that so that we track it
Yes,
and yeah,
I will. I will. Yeah, yeah. I tried. I
awesome.
want to measure everything about this and
Yeah,
create
yeah.
the issue. Yes, yeah.
I fully agree on all of those decisions. Yeah. Yeah.
Yes.
Okay. Those were my questions. I don't have anything more.
Awesome, awesome. And thanks, Tommy, because your questions make this more clear and we can like discuss and make sure everyone understands what is happening.
Of course.
So yes, that's great. And that's all also for me. So I'm going to continue working on this today. And I'm curious about why this is taking so long. That's why I'm also interested in finding out. So yeah, I'm going to have more information tomorrow. And I just delve a little bit into the subnet addition to the duties and how this will be pre-calculated, but I don't think it will take me more than 1 or 2 days. It should be an easy PR. So yeah, I'm going to continue working on that for now. So that's all for me. Have a good one. Have a good day, everyone, and we can see you